Hi there, it's Aquavital here, and today we're gonna talk about Go slices. Slices in Go are very convenient data structures. If you got used to languages like Python or JavaScript, you may consider Go slices as a kind of dynamic arrays used in that kind of languages. However, understanding how slices work exactly can help you avoid some not very obvious mistakes. At some point, you may debug your code and find out that things you were sure were immutable actually were not. And you go like, why append function breaks my source data? I do not expect it to change. Or in some cases you may find your code concerned with shrinking and stretching slices becomes dramatically slower than you would expect. The thing is, slices are not exactly dynamic arrays. They are just lightweight data structures built upon an underlying static length arrays. Basically, slice has some pointers to it. Those make the slice understand what array it's been built upon, which position of the array the slice starts from, and where it ends exactly. When you create a slice with make operator, you can choose its initial length as well as the length of the underlying array, like this. This will allocate 10 bytes of memory for the array, and first 5 bytes will be used by our slice. You can always get these two lengths using len, which will give you 5, and cap. Cap apparently stands for capacity, and it will give you 10. What happens if we shrink the slice? Let's have a look. Let's say s equals s up to second element. As you can see, len is now 2, but the capacity is still 10, as the underlying array hasn't changed. But what if we shrink it another way? Let's say from third element to the end of the slice. Of course, length is still 2. But what about capacity? What happened exactly? Basically, when we allocate an array, Go finds a continuous range of memory, in our case of length 10, and then we declare the slice upon it. Now our slice points to the 0th element as the starting point, and to the 4th element as the end of the slice. The capacity of the slice is the length of the continuous range we just allocated. When we shrank the slice the first way, Go said, OK, I'll move the end pointer to point to a new value. But when we shrink from the third one to the end, look what happens. Go moves the start pointer to the new point. So the continuous region available for our slice from now on starts here. So we have only 7 bytes of memory left. Let's see what happens when we extend slice beyond its capacity. Let me delete that as we don't need it anymore. Now as we have 5 elements long slice, let's add 6 elements more. As you can see, the slice length is 11, which is quite logical. However, its capacity is now 32. Why is that? It's because as we hit the end of the underlying array, Go created a new one, big enough to handle the new slice, and a bit of an additional space to cover our future needs. Next time the slice hits the bounds, Go runtime will create a new array twice as long, so the capacity will be 64 and so on. Having learned that, we came to an interesting example. Let's say we have a slice A of 10 bytes, like this. Let me delete that. A equals bytes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bytes, and it works. And now let's make another slice which consists of 2 first elements of A and 2 last elements of A. And let's use built-in append function as well. and let's have a look. Println b, and we don't want to see this yet. The first question is actually easy to answer. What does the B slice consist of by now? Let's take a look. 0189, as we expected. But now the second question is a bit more complicated. What does the A slice consist of by now? If you came from the world of Python, you would probably think that A remained unaffected. Let's have a look. Let's delete that. Let's run that. A gives us 0189, 456, and so on. What happened exactly? You probably guessed what happened here. Append always works within the underlying array. Since it has enough room to append 2 elements after 2 elements, it will use the same array without allocating any additional memory, no matter if we're creating a new slice or not. Actually, in this case, the slice B is built upon exactly the same array as A. What I actually mean by saying enough room to append is, I'd better give you another example. Let's recreate the slice B from first 7 elements and last 7 elements, like this. As you can see, now B is bigger than the capacity of A. In this case, Go has no choice. It has to create another array of bigger size and copy elements to it. That means that the slice A remains unchanged. Okay guys, that's all for today. Thanks for watching.